you choose, so it doesn't matter. So for the first time, we're going to cover a little bit of close to Algebra 2 and the pre-calculus, because this is actually covered in Algebra 2, but a lot of teachers choose not to cover it. So I'm going to cover it, which is domain of the functions. There's two types of situation that you have to worry about domain. So, but today we're just going to talk about one type. So we're going to talk about domain of rational functions. Finding, where's my good marker goes? Okay, find domain of rational functions, rational expressions. First of all, let's understand what is rational expression. Rational expression is some polynomial or some over some polynomial. So the simplest one I can think of, it says 1 over x minus 2. That's actually rational expressions. Are we okay here? Okay. So there is something here says domain. So what is domain? Can anybody really define domain for me?
X.
X.
Like, I think it's
Okay, go ahead.
all of the possible x values.
All the possible x values. Good. For this expression, right? Okay, so can x equal to all the number in this case? Yes, Josephine?
X can't equal 2.
Yeah, it can't equal 2.
Why you cannot equal to
Because
2?
then you have,
1
if you
over
replace,
0.
if you replace x, 2 with x, and 2 minus 2 is 0, you have 1 over 0, and that's undefined.
Right, so you cannot have an undefined situation. So you can have 0 divided by some number. So 0 divided by any number is fine, it's okay, which is lead to 0, right? But if you have number over 0, okay, so one thing you need to understand in math, thou shalt not divide by 0. It's like the first commitment in math, okay? If you divide by 0, the world's gonna go upside down. And do not divide by 0. If you had divided by 0, that means not okay. So this is when when shit going down, right? Okay, so you cannot have number divided by 0. If you have the number divided by 0, that's don't copy this down. Don't see this.
What stuff? It
Okay.
says stuff.
Is it ship?
Okay, so number over 0 is not okay. So you cannot have number over 0. So therefore, I need to find the domain of this functions. Domain of this function, what x can equal to, and usually better to define is what x cannot equal to. Okay, so in this case, is usually is when after factoring. So domain. After factoring, and set it cannot equal to 0. So when denominator after factoring cannot equal to 0. So after factoring cannot equal to 0. This xn minus 2 is factorable. Well, it's technically factorable in algebra 2, but we don't want to do that because it's actually square root x plus 2 and square root x minus 2 is actually factorable, but I don't want to do that. I just want to deal with just, pretty much linear. So I'm going to set a denominator, right? And we're going to say it cannot equal to 0. Is that very hard? Denominator cannot equal to 0. If denominator equal to 0, that's where things going to go back in math. So what I'm going to do is I'm going to simplify this. I'm going to solve for this. This is inequality sign. You still can solve just like an equal sign, which is nice. So I'm going to add 2 on both sides. So x cannot equal to 2. Does that make sense? But how do I graph that x cannot equal to 2? So if I want to graph it, right, it's pretty much it's like this is 0, this is 2. And this is pretty much this. And it's gonna be negative infinity, infinity. If I were to graph a number line, this is my solution. My domain is gonna be any number between negative infinity to 2 and then 2 to infinity. Now, a deeper way is with something called interval notation. Have you guys ever heard about interval notation? So those are what we're gonna use more in pre-calc level. In algebra 2, higher level algebra 2, we're gonna use as x can equal to, this is algebraic notations. We're gonna use something called interval notation. Interval notation is just basically reading from left to right. Make sure, reading like how you're reading this, like interval notation. You don't read notation interval. That doesn't make sense. You read from left to right. Does that make sense? So whatever the solution is going to be, in this case, domain is the solution. So domain is going to be from negative infinity, because this is part of the solution. So it'll be negative infinity to 2, parenthesis, union 2 to infinity. This means exactly the same thing as this, but this is a better way to represent it, because in higher level math, we usually prefer interval notation that tells me anything. Now, what happens when it's bracket? What does bracket mean? Yes. Go ahead. No, it's okay. Go ahead. What if I have to put down bracket? That means what?
Like the end of the state.
Yes, it is technically true, but it's not what I'm looking for, but it's technically true. That means you can equal to 2. But as a parenthesis, you cannot equal to 2. Parenthesis, you cannot equal to 2. So that means you cannot equal to 2. But if it's bracket, then you can equal to 2. Then that means the circle is filled in. Then I can say it's from negative infinity to positive infinity. So that's going to be negative infinity to 2, 2 to infinity. Does that make sense? But that just means x cannot equal to 2. But you cannot put a bracket on infinity. Why you cannot put a bracket on infinity? Yes.
Because you can't like contain infinity, or can't like that can't be part of the trying to find the word. Well, like bracket represents like it. That's you within the equation. Like you can use it within the equation. You can't technically use infinity because it's infinite amount of numbers.
Infinite number. Well, why can you? So the way I kind of give an analogy is this: as you cannot reach infinity, right? So just say, for example, my house to your house is infinitely long. That means it doesn't matter what kind of car you drive. You'll never be there. You can drive a car that is a billion light year per miles, per hours, and then you're still not gonna get there, because once you drive a billion miles in an hour and drive a billion miles, you're still not gonna get to the house. Even you go awfully far, but you're still not gonna get. So infinity is cannot equal to. Also another analogy I give the students, you cannot reach infinity, but there's only one thing can reach infinity. What's that one thing? No. What? No, not pi. It's a corny joke.
42.
Jokes. There you go, Buzz Lightyear.
Oh my!
I really didn't think that was it.
Buzz Lightyear, right? Only Buzz Lightyear can reach infinity and beyond. So if we're not Buzz Lightyear, you're gonna put a parenthesis there. So make sure you put a parenthesis on the infinity, never a bracket, ever, ever, ever again, because I know you're not Buzz Lightyear. Any questions about this part? Okay, so I'm gonna give you another one that's a little bit harder. So let's say it's 3 over x squared minus 25. So how do I find domain of these functions? Now, domain of rational functions is when denominator after factoring cannot equal to 0.
So you can do.
Hold on, let other people think first. I know some of you guys can raise your hand very quickly, and I know it's that, but when you speak it, sometimes I want you to hold back. What Miss Weiss used to do is this. Miss Weiss had this student named Gianluca. Gianluca always get every question right, so he will communicate with Gianluca. He will say, every answer you got it right, Because when he says the answer is 2, then everybody whole class says the answer is 2. Because he was the smartest person in the classroom. If it says 2, then it's not 2. So what Ms. Weiss is really smart is this. Ms. Weiss actually communicate with Gianluca says this. He says every time you get an answer, you're gonna add 2 on top of it. So that was very smart. So he will raise the answer, he will say the answer is 4, but technically Ms. Weiss will know that answer is actually 2. But everybody will follow his answer and everybody got it wrong. So Ms. Weiss is a very clever teacher. Anyway, that's from
She
you.
never told me that.
That means you're not smart enough.
No.
I'm sorry. No, I'm just kidding. You might be smart, but it's not Gianluca level yet. You will be though. Gianluca make it Caltech, so it's a very special person. Pay attention to when you speak out the answers, because when you speak out answers, other people stop trying. So if you stop trying, so wait until some time. So make sure you get this. So how do I find the domain of this function? See if you can do it. It might be more difficult than the previous one, yes. So what did I say? When denominator after factoring. So you have to factor this, right? So I'm gonna factor this, right? X plus 5 and x minus 5, right? And then, do I care about numerator? No, numerator can be whatever, any function doesn't matter. But the denominator is the key. So x plus 5, x minus 5 cannot equal to 0. If that cannot equal to 0, that means x plus 5 cannot equal to 0. X cannot equal to negative 5. Does that make sense? X minus 5 cannot equal to 0. X cannot equal to 5. So pretty much a algebraic notation is right here. The graphic notation is going to be negative 5 and 5, and infinity and infinity. And then you're going to have a perfect circle here. Cannot including those values, because pretty much every value is set to negative 5 and 5. So this is the graphic notations, the domain. Now, what do I do interval notation? How many intervals are they?
2.
Not 2. It's actually 3 intervals. So if you read it from left to right, so it's going to be what? Negative infinity to what? Negative 5 union, negative 5 to what? 5, not to 0, because 0 can equal to 0. 0 squared is 0, right? 3 over negative 25 is still okay. So, and then 5 to infinity, and that's going to be union. Make sure you don't put any brackets here, because you cannot equal to infinity, you cannot equal to 5, you cannot equal to negative 5. So none of this, they should be a bracket. Sometimes your answer can have bracket, but not this case. So when we talk about radical functions, then we're going to be like this. Question about this part. Okay, you can try one more before we go to simplify rational expression. So let's try one more. So I have an x plus 2 over x squared minus x minus 6. I want you to find domain of those functions. So let's find domain of this function. Find domain of this expression, rational expression. Should be very easy. Now, can this function be full term? Yes. Which is vector by grouping. Can it be cube? Yes. Now cube is a little bit harder because of the difference of a cube. So because one is not solvable, the other factor is solvable. So, but in this case, it's just something very easy. So what I do, I'm gonna factor the bottom, right?
Yeah.
This top factorable, not needed, it means,
That's not.
yeah, you can factor this, but it's not needed. But I hear we're gonna factor this, what do you gotta factor?
X minus
X
3.
X minus 3,
X plus 2.
x plus 2, right? Now, some people tended to cancel this. I know that makes sense, but it's not making sense for its domain. Why is domain you cannot cancel? Because technically you gotta look at the original equation, not the simplified equation. So I know you can simplify this, make it 1 over x minus 3, but you don't wanna do that if I'm looking for domain. Domain, you're gonna look at the original expression, at least the factorable original expression, and look at the denominator. You're gonna say x minus 3 and x plus 2 cannot equal to 0. And then x minus 3 cannot equal to 0, x plus 2 cannot equal to 0, x cannot equal to 3, x cannot equal to -2. In this case, if I simplify it, in this case, you cannot equal to -2 because you're gonna have some number over 0 over 0. Now, for those of you guys who don't know what a 0 over 0 is, 0 over 0 is okay. It's not undefined. Remember this. Those of you guys are advanced students, remember this. 0 over 0 is not undefined. It's undetermined. Okay? In next year, you're gonna learn something about calculus, what we can do with that situation. But 0 over 0 is temporary okay. It's not okay at this situation because it's gonna give you 0 over 0. But in 0 over 0 for us, the next level math, that is okay because it must be something you can do about it. But in this year, you thou shalt not divide by 0. Okay. But 0 over 0 in advanced math is gonna be undetermined instead of undefined. So x cannot equal to 3, x cannot equal to -2. If I would draw it, it's gonna be -2 and 3, and that's gonna be open circle, and that's gonna be like this. Does this make sense? And what's my interval? -infinity to -2,
Yeah.
union from -2 to 3, union from 3 to infinity. Does that make sense?
Yes.
Okay, yes. Denise?
I forgot, how do you tell when the circle is like open or closed or filled?
I hear we can say cannot equal to 3, so it's cannot equal to the open. And cannot equal to 2 is an open. If it can equal to 2 and equal to 3, then that's gonna be closed. Good question. Okay, so let me give you another one that says, I don't know, 1 over 5x to the third minus 20x. See if you can find the domain of this. So this is a factoring questions, it's not a question about other things, so. This is the last one, so we can talk about other things. So let's find domain of the situations. Remember what's first thing on factoring? There you go, GCF. Okay, so make sure you, and this question is on your test, I think, something like that, yeah. How to factor 5x cubed minus 20 plus 20. Nicholas, you seem like you dropped a pencil, so how many interval you got? Yes, how many interval you
I
got?
got 4 because there were three different terms that were like, that will make it undefined.
Right, so it's 3 number cannot equal 2, so if it's 3 number, then you should have 4 intervals. You got 4 intervals, okay? So make sure you do that, so you gotta be careful, okay? So what we're gonna do is factor out GCF, right? So what is GCF here? 5x, right? And we're gonna factor more. Right? And then you say, okay, denominator cannot equal to 0, so denominator cannot equal to 5x cannot equal to 0, x plus 4 cannot equal to 0, x minus 4 cannot equal to 0. So if x cannot equal to 0, x cannot equal to -4, x equal to 4. So pretty much it's gonna give you 0, -4, and 4. Open circle on all of them.
X squared minus 4.
Oh, 2, sorry, my bad, 2, I did it too quick, thank you. So this is a +2, and this is a -2, and this is a 2. So then, this one should be 2, and -2, did too quick, sorry. So now, I should have 4 intervals, so it'll be -infinity to -2, union from -2 to 0, union from 0 to -2, 2, sorry. And then union from 2 to infinity. So you should have 4 intervals here, and that's what the interval notation is going to be. Remember, this is more important than anything else. This is kind of a little bit like introduction of pre-calc level. It's not even in pre-calc level yet. Technically, in algebra 2, you should cover this. Do you remember to cover this in algebra 2? No? Kind of, okay, depends which teacher you come from, but should cover extensive in algebra 2. But not, so we can count this more to a pre-calc level. Okay. Question about finding domain. There's only 2 types of, 2 major type domains gonna cause issue. One is rational expression, another one's radical equation. And there's one other one is gonna be logarithms and trig equation, but we're gonna talk about that when we get there. But right now, we don't deal with there yet. So radical, rational, logarithms, and trig. That's trig especially function like tangent, secant, cosecant, but not sine and cosine, because sine and cosine are smooth. Question about this part. Okay,